When encountering an ungrounded refrigerator circuit, several factors must be considered. Rewiring the circuit is generally the preferred solution because it establishes a proper grounding path, thereby eliminating potential electrical hazards. However, it's important to acknowledge that rewiring can be an expensive and time-consuming undertaking. Installing a ground fault circuit interrupter, or GFCI, is another option. GFCIs are designed to detect imbalances in electrical current. If a fault is detected, the GFCI trips the circuit, which can help to prevent electrical shocks. Although refrigerators are not typically connected to GFCIs, this may be a viable option to provide a degree of protection in this specific situation. As an electrician, you have a professional responsibility to ensure the safety of your customers. If you're aware of a potential hazard, such as an ungrounded appliance, failure to take appropriate action could lead to liability. Considering the liability concerns, especially since the customer is currently not residing in the dwelling, it's advisable to take these steps. Firstly, document the situation thoroughly. Take photos and carefully note the condition of the existing circuit and the refrigerator. This documentation will serve as evidence of the hazard as it currently exists. Secondly, contact the customer to inform them about the ungrounded refrigerator and the potential risks involved. Explain your recommended courses of action to address the situation. Thirdly, recommend rewiring the circuit as the best overall solution. Provide the customer with a detailed estimate of the cost involved in rewiring. Fourthly, if rewiring is not immediately feasible for the customer, offer the installation of a GFCI as a temporary measure to provide some level of protection. Be sure to clearly communicate to the customer that this is not a permanent solution and that rewiring the circuit should be completed as soon as possible. When undertaking any electrical work, ensure full compliance with all applicable electrical code requirements. This includes using the correct wiring methods, appropriate overcurrent protection, and proper grounding techniques. Before proceeding with any work, obtain written authorization from the customer. This is essential for legal and ethical reasons. Always prioritize the safety of the customer and anyone else who may use the dwelling. This includes turning off the power to the circuit before starting any work, using appropriate personal protective equipment, and carefully inspecting all work before restoring power. When dealing with an ungrounded circuit, a few options exist, each with advantages and disadvantages. One option is to rewire the circuit. This involves replacing the existing 2-wire cable with a 3-wire cable that includes a grounding conductor. The grounding conductor is then connected to the grounding system of the house, providing a path for fault current to flow back to the source. This is generally considered the safest option because it provides a low impedance path for fault current, which will cause the circuit breaker to trip quickly in the event of a ground fault. However, rewiring can be expensive and disruptive, especially in older homes where the wiring is difficult to access. Another option is to install a GFCI outlet. A GFCI outlet is designed to protect people from electrical shock. It works by monitoring the current flowing through the circuit and tripping the circuit if it detects an imbalance. This can happen if someone comes into contact with a live wire and provides a path for current to flow to ground. GFCI outlets are relatively inexpensive and easy to install, but they do not provide the same level of protection as rewiring the circuit. They will only protect against electrical shock, and they will not protect against fire hazards caused by ground faults. A third option is to do nothing. This is the least desirable option, but it may be acceptable in some cases. For example, if the appliance is double insulated, it does not require a ground connection. Double insulated appliances are designed with 2 layers of insulation to prevent electrical shock. However, it is important to note that even double insulated appliances can become hazardous if they are damaged or misused. Ultimately, the best course of action will depend on the specific circumstances. It is important to consider the age of the wiring, the type of appliance being used, and the budget. It is also important to consult with a qualified electrician to get their professional advice. Let's elaborate more on the specifics of dealing with ungrounded circuits and the nuances of each potential solution. First, rewiring the circuit to include a grounding conductor offers the most comprehensive safety upgrade. The grounding conductor, typically a bare copper wire or a green insulated wire, provides a dedicated path for fault current to return to the electrical panel. This low impedance path ensures that in the event of a ground fault, a significant amount of current will flow, causing the circuit breaker to trip rapidly and cut off power to the circuit. This rapid tripping minimizes the risk of electrical shock and reduces the potential for fire. When rewiring, it's crucial to use appropriately sized conductors as specified by the National Electrical Code, or NEC. The size of the conductors must be adequate for the anticipated load of the refrigerator. In addition, all connections must be made securely and correctly to prevent loose connections, which can cause overheating and arcing. The grounding conductor must be properly connected to the grounding system of the house, which typically involves connecting it to a grounding electrode system, such as a ground rod or a water pipe. While rewiring offers the highest level of safety, it can also be the most challenging and expensive option, especially in older homes. Accessing the existing wiring may require opening up walls or ceilings, and the cost of materials and labor can be significant. Secondly, installing a GFCI outlet provides a significant improvement in safety, although it doesn't address the underlying lack of a grounding conductor. A GFCI outlet works by constantly monitoring the current flowing to and from the appliance. If it detects a difference of more than a few milliamperes between the outgoing and return current, it assumes that some of the current is leaking to ground, possibly through a person. In this case, the GFCI will trip the circuit very quickly, typically within a fraction of a second, to prevent a dangerous electrical shock. GFCI outlets are relatively easy to install and are less expensive than rewiring the entire circuit. They can be installed in place of the existing ungrounded outlet, providing a readily accessible safety upgrade. However, it's important to understand that a GFCI outlet does not provide a grounding path for the appliance. This means that if the appliance has a ground fault, the GFCI will trip, but the appliance chassis will still be energized. While the GFCI will prevent a dangerous shock if someone touches the energized chassis, it won't eliminate the potential for a fire hazard. It is also important to note that the NEC allows the use of GFCI protection as a means of providing protection in certain ungrounded circuits. The NEC permits replacing an existing ungrounded receptacle with a GFCI receptacle, and it requires that the receptacle be marked with the words "No Equipment Ground." The requirement for marking is to inform users that the receptacle is not grounded and that they should not use it with appliances that require a ground connection. Thirdly, consider the specific requirements for refrigerator circuits. While the NEC generally requires that all new receptacle outlets be grounded, there are some exceptions for existing ungrounded installations. However, it's important to carefully evaluate the specific requirements for refrigerator circuits to ensure compliance with the code. Some local jurisdictions may have stricter requirements for refrigerator circuits, especially in new construction or major renovations. Also, consider the potential for nuisance tripping of the GFCI. Refrigerators, especially older models, can sometimes cause nuisance tripping of GFCIs due to motor starting surges or other electrical noise. If nuisance tripping becomes a problem, it may be necessary to consider other solutions, such as rewiring the circuit or using a different type of GFCI outlet that is less sensitive to nuisance tripping. When making a decision about how to address an ungrounded refrigerator circuit, it's important to carefully consider all of the factors involved, including the age and condition of the wiring, the type of appliance being used, the budget, and the applicable electrical code requirements. It's always best to consult with a qualified electrician to get their professional advice and ensure that the chosen solution is safe and compliant with all applicable regulations. Documenting the existing conditions is crucial. Take detailed photographs of the wiring, the outlets, and the refrigerator. Note the age and condition of the wiring and identify any potential hazards, such as frayed wires or loose connections. This documentation will serve as evidence of the existing conditions and will be helpful in explaining the situation to the customer. Communicating with the customer is also essential. Explain the risks associated with the ungrounded circuit and discuss the available options for addressing the situation. Provide the customer with a written estimate of the cost involved for each option, and be sure to answer any questions they may have. Obtaining written consent from the customer before proceeding with any work is critical. This will protect you from liability and ensure that the customer is fully aware of the risks and benefits of each option. Emphasize the importance of safety. Explain that the ungrounded circuit poses a potential risk of electrical shock and fire, and that it's important to take steps to mitigate these risks. By taking a proactive approach to addressing the ungrounded refrigerator circuit, you can help to ensure the safety of the customer and protect yourself from liability. Here is a further breakdown of the code implications and practical considerations for each approach. Firstly, the rewiring approach. The National Electrical Code, specifically Article 250, provides detailed requirements for grounding and bonding. When rewiring, ensure the new circuit meets current code standards. This includes using a 3-wire cable with a dedicated equipment grounding conductor sized according to NEC Table 250.122. The grounding conductor must be connected to the equipment grounding bus in the panel board, which is bonded to the neutral bus and the grounding electrode system. Check the voltage drop on the new circuit. Long runs of wiring can result in voltage drop, which can affect the performance of the refrigerator. Use NEC Chapter 9, Table 8 to calculate the voltage drop and ensure that the conductor size is adequate to keep the voltage drop within acceptable limits. Secondly, the GFCI protection approach. NEC Section 406.4D2 addresses the replacement of non-grounding receptacles. It allows the replacement of a non-grounding receptacle with a GFCI receptacle where there is no equipment grounding conductor. However, it requires that the GFCI receptacle be marked No Equipment Ground. This marking is intended to inform users that the receptacle is not grounded and that they should not use it with appliances that require a ground connection. When using a GFCI receptacle on an ungrounded circuit, it's important to understand that the GFCI will only protect against ground faults. It will not protect against other types of electrical faults, such as short circuits or overloads. Consider using a combination of SI/GFCI breaker for added protection. An arc fault circuit interrupter, or a SI, protects against arc faults, which can cause fires. A combination of SI/GFCI breaker provides both ground fault and arc fault protection. Thirdly, practical considerations. Evaluate the condition of the existing wiring. If the existing wiring is old, damaged, or deteriorated, it may be necessary to rewire the entire circuit, regardless of whether you choose to install a GFCI receptacle. Check the capacity of the electrical panel. Ensure that the electrical panel has sufficient capacity to handle the load of the refrigerator. If the panel is already fully loaded, it may be necessary to upgrade the panel to provide additional capacity. Consider the energy efficiency of the refrigerator. If the refrigerator is old and inefficient, it may be worthwhile to replace it with a new, energy-efficient model. This can save the customer money on their electricity bill and reduce the overall load in the electrical system. Discuss the options with the customer and provide them with a written estimate of the costs involved. Be sure to explain the pros and cons of each option and answer any questions they may have. Obtain written consent from the customer before proceeding with any work. This will protect you from liability and ensure that the customer is fully aware of the risks and benefits of each option. When working on electrical systems, always follow safe work practices. Turn off the power to the circuit before working on it, and use appropriate personal protective equipment such as gloves and safety glasses. By carefully considering all of these factors, you can make an informed decision about how to address the ungrounded refrigerator circuit and ensure the safety of the customer.